Welcome to Lavanya's computer classes. In this video, I will explain heap tree. So, what is an heap tree? In the previous classes, in the previous videos, I already explained what is a heap tree and what are the types of heap trees. Now, we will explain how to construct a heap tree with proper examples. I will take some elements. Through that elements, how to construct a heap tree. For example, you consider these elements. I will consider these elements 10, 17, 2, 3, 27. For these elements, construct a heap tree. Construct a heap tree. Actually, we have two types of heap trees are there. One is max heap and second one is min heap. Already I am explained what is max and what is min. Max heap means the root node is always greater than its children node. The root is always greater than its children node. Min heap means the root is always smaller than its children. So, first I will consider max heap. Now, I tried how to construct a max heap for these elements. So, in these elements there are 5 elements are there 10, 17, 2, 3, 27. So, first element, consider a first element. Step 1. Consider the first element is a root node. So, 10 is a root node, that is over. Then step 2. What is the step 2 mean? To take next element 17. So, what is 17 means? It is a binary tree. First go to left hand side, then only right hand side. So, already 10 is our binary root node is there. Take the element 17. 17 is keep it as left hand side of the root node. So, 10 is the root node and 17 is the left child. But I already said I will construct a max heap. So, what is the properties of max heap means? Root is always greater than its child. Either it is a left hand side or right hand side. So, but here 10 is the root node and 17 is the children node. So, 17 is more than 10. So, it is not satisfied the max heap property. So, in this case just swap it. Swap the elements of 17 and 10. So, after swapping, step 2, 17 is coming like a root node and 10 is coming its left hand side children. So, now again check the properties of max heap. Here 17 is the root node and 10 is the child node. So, max heap property, root is always greater than its children node. So, it is satisfied max heap properties. Now, consider next element is 2. So, what is 2? 2 is next element 2 means 2 is keep it in the right hand side of root node. Okay. So, this is also max heap because root node is 17 is more than its both left and right children. So, there is no swap. So, it is a max heap property. Then next consider the element is 3. So, next element is considered 3 means already here 17 is there. Left hand side children is 10, right hand side children is 2. The new element 3, the 3 is keep it as like left hand side of 3. Now, again check after inserting the new node, again we check it satisfied the max heap or not. So, what is the max heap property here? 17, it is the root node. The root node contains 2 children, 10 and 2. Both the children are smaller than its root node. So, it is a max heap property. Then coming to left subtree, the children node is 3, its root node is 10. So, 10 is more than 3. So, all are satisfied the max heap properties. Then last element. So, what is the last element? Last element is 27. So, keep the 27. Where we keep the 27 means 27 is 17. So, right hand side of 10. 27. After keeping this, again check the property. Root node is 17. Both the children of 17, 10 and 2, both are smaller than 17. No problem. It is a max heap property. But whenever coming to 10, the children of 10 is 3 and 27. 3 is smaller than 10, but 27 is not smaller than 10. So, according to max heap property, we just swap it. 27 and 10. After swapping, the tree is like this, 27 coming into 10's place, then 3, then 10 is here, then 2, and again compare it. Again here root node. Your root node is 17. What are the children of root node? 17. The children are 27 and 2. But according to max heap property, the root node is always greater than its children node, but here it is not satisfied. So just swap these two values. We swap to these two values. 27 is coming to here, 17 is here, 2, then 3, here 10. So now again check it. What is here? Root node is 27. 27 has two children, 17 and 2, both are smaller than its root node. So it is max heap. Coming to down, again 17 is a subtree. 17 has two nodes, two children, 3 and 10, left and right children. Both the children 3 and 10 are smaller than its root node 17. So total diagram is obey the max heap properties. Like this we consider, we construct a max heap property. Now I will explain how to construct a min heap with the same numbers. So how to construct a min heap for this same numbers. So min heap, what is the min heap property? Means the root node is always smaller than its children node. The root node is always smaller than its both left and right children. So using this formula, using this property, we construct a max heap, min heap. So first consider first element. So what is your first element in this list? 10. So 10 is considered as 10 is the root element. So anyway only one element is there, it is satisfies all the properties of min heap. Next consider next element 17. So keep the next element is left hand side of root node 17. After adding the new element in the root node, again check it min heap property. What is the min heap property? Root node is always smaller than its children node. Here root is 10 and children node is 17. So root node 10 is smaller than 17. So it obeys the property of min heap. So no problem, leave it. Next element is 2. So keep the next element 2 at the right hand side of root node. So this one is the root node. So again check it, it is the min heap property or not. Here root node is 10. 10 has two children, 17 and 2. Both here minimum root node is minimum. Here left hand side no problem. But coming to right hand side, the right hand side element 2 and root element is 10. The 10 element is not smaller than its right hand side children. So it is not obey the min heap property. So just swap these two elements. After swapping these two elements, the heap tree is coming like this. 2, here 10, here 17. After swapping the elements, again we check the properties of min heap. Here root node is 2. Root contains two children, left and right children, 17 and 10. So compare it to its children node, 2 is the smaller. So it obeys the min heap property. Now go to 3. So where we keep 3 means left hand side of 17. Coming to here. Again after adding one more new node, just check the property of min heap. Up to here it is satisfied, otherwise root node is 2. Its two children are 17 and 10, both are more than its root node. Coming to one more level, here left hand side children is 3, its root node is 17. But here 17 root node is more than its children node. So it is not satisfy the min heap property. So just swap these two values. After swapping these two values, 2 is coming here only. Instead of 17, 3 is here and 17 and 10 is right hand side. And once again, because it is coming into only one level, but 3 is changed to here, but 3 has one more parent. So again check the min heap property. Here parent node is 2, its children node is 3. So, children mini heap. So, root node is smaller than its children node 3 and 10, and here 3 is root node, 17 is the children. So, it is smaller than its children node. So, it satisfies the min heap properties. Last number is 27. Where we keep the 27 means 27 is adding here, right hand side of 3, 27. Again check it. Properties. Here left subtree 3. It contains two children 17 and 27. Both the children are more than the root node. That means root node is smaller than both the children. So it is min heap property. Coming to next level, next higher level, 3 has parent node 2 and 2 is the root node. Root node contains two children 3 and 10. Both the children are more than 2. That means root is here smaller than its children. So it satisfies the min heap. So this is called as min heap. So like this we can construct max heap or min heap. Thank you for watching my video. If you like my video, just like it, share it and subscribe my channel. Thank you.